Hello everyone, I am Mark from the OpenSecFlow community. Today, I will guide you to NetDriver and I apologize for my English upfront, hopefully captions are mostly correct. NetDriver is a tool that makes network automation as simple as calling on an API. For this demo, I will be guiding you through basic UG installation so you can do it later yourself. So, why would you need to use NetDriver agent? Tools like NetMic or Paramico are already well known amongst us engineers, who frequently develop network automation or network scripts. However, during actual use, we need to manually manage its connections. Simultaneously, we also need to process the device output for our input commands. This requires performing manual state maintenance and judgment, which is relatively complex. NetDriver, however, is a tool we developed based on product environment experience. So, what improvement does it offer compared to NetMic or Paramico? First, it provides a HTTP RESTful API interface that allows us more easily, as if using an API, execute commands on network devices and create connections. Additionally, it offers connection persistence and capability with built-in connection pool. In scenarios involving mass command deployment, we can efficiently utilize this connection pool to execute commands at high efficiency, without needing to create and destroy connections each time. Furthermore, we implemented a command execution queue. In high currency scenarios, different business processes might simultaneously issue commands to switches or routers. The command execution queue ensures that commands are executed on the device in orderly sequence without interruption, guaranteeing efficient, orderly, and correct execution. Next, our entire development is based on the new async SSH library from the Python community. Async SSH is implemented on Python's async queue. In high concurrency scenarios, its performance is significantly better. We also support features like automated VSES and mode switching, which will be demonstrated later. As we know, network devices have different modes. For example, Cisco devices start in login mode. You need to enter the enable command to enter privileged mode for configuration or verification tasks. Then, after entering configure terminal, you need configuration mode to input configuration related commands. Similarly, certain firewalls support virtual systems like VSES, such as Palo Alto's VSES, or Juniper Logical Systems. With these virtualization systems, we often need to manually enter commands to switch between different virtual systems in order to execute the correct configurations. Therefore, NetDriver agent automates this handling. It can automatically handle mode and VSES switching. Finally, I want to emphasize that currently NetDriver agent supports over 20 device types, including mainstream vendors like Cisco, Huawei, Juniper, Fortinet, Palo Alto, and more. For specifics, please visit our community page. Without further ado, let's move on to our first segment, environment preparation. For this lab, you can run it on Mac OS, on Linux systems, and also on Windows. But that's a bit more complicated, as it requires installing WSL. For this demo, I'm using a Mac. We will assume you already have a Docker installed, since running NetDriver agent via Docker is relatively simpler. Okay, besides the basic environment, for this course we also need network devices. These devices can be real physical devices, or they can be virtualized devices using virtualization software or lab platforms. This time we will be using two devices created with the PN8 lab virtualization software, two network devices. One is Palo Alto PA and the other is Juniper CRX. Here is their IPs, usernames and passwords. Before connecting, we need to set up appropriate permissions. For this segment, we will assume it's already configured, so we can test directly on our lab machine to verify our login credentials for these devices are correct. Let's test the PA device. Okay, after entering the username and the password, we can see we logged into the Palo Alto device. This is his prompt. And then try logging into the Juniper device. We also successfully logged into the Juniper device. Oh, we logged out. For Juniper, you type quit to exit. Alright, the next step is to install our NetDriver agent. We can follow this path. First, find an empty directory. As you can see, my directory is currently empty. In this directory, we first create the folders we will use to hold the configuration files and logs. Then we download our configuration file into this directory. Oh, here is our interface. Oh, download complete. Let's look at the current directory structure. We can also briefly browse our configuration files. The mainly configuration items like log levels and some sanity check configurations etc. I won't go into too much detail here. Okay, our next step is to run our command. As you can see, we use Docker to pull the latest NetDriver agent image. We also map port 8000 and mount the configuration and log directions we just created. Great, we run it successfully. It's our first time running this. It might involve pulling the image, we can also a bit slow. Alright, we can see the container is now running. We can check the logs or use a curl command to call this health check endpoint to see if it's running normally. Oh, we see it returns a healthy status, indicating it started correctly. Next, let's look at its logs. In these logs we can see there are many prefixes, but you can see it has completed the plugin loading process. Here we also see this started successfully, and furthermore it has loaded 43 plugins. That's good. That's nice. Those plugins are something we can extend later. Plugins support different device types, model and versions. Alright, let's exit. Okay. We also provide debugging, API testing, and a documentation interface based on OpenAI Swagger. We can open it using this link. Oh, here's our interface. Here we can see we primarily have two main points. At this stage, one is connect endpoint and used to test connections between us and the device, and the other endpoint is our CMD endpoint, which is used for command execution and retrieving in return values. Let's look at the connection endpoint. Here we can see how to fill in specific properties, which fields are required and which are optional. We can view all this here. Okay, let's go back to the main interface. Alright, for step 2 we will proceed to make an API call. We will make this API call using curl from the bash terminal. We could also use the Swagger interface we just saw. For my first test, I will use curl to connect to our PA device. Let's see what it returns. Copy that. Yep. The first connection involves the initial connection setup process. The process might be a bit slow depending on network speed and specific device characteristics. We can see the first time it took a few seconds, maybe 4 or 5 seconds, which is relatively slow. However, with our connection persistence capability, if we make a second call, it will be much faster. We can see we filled in some parameters here. The first one is the protocol currently supports SSH. We might use protocols like Telnet in the future. Then IPI port, username, password, and the enable password. This is enabled password is mainly for devices like Cisco, or those emulating Cisco CLI, such as RI devices. They require an enabled password. For our PA it doesn't, so we will leave it a blank. Then vendor, which is the middle version character encoding and timeout settings. We can see for vendor we choose Polo Auto, wait to file to be checked in the Swagger interface we saw earlier. It's the specific values you can enter. For model we select PA. For version, since each plugin currently only has a base version, we can enter any version number here, or we can enter the specific PA version. However, in the future use, we might encounter different version numbers where commands vary or its parameters vary. In this case, we can extend the plugin and specify the corresponding version number to have NetDriver agent load the current. This way we can achieve extendability and support. Next up is other device, the new device we mentioned. We can use our Swagger interface to make the call. For this call, we can simply copy over the connect parameters. To connect parameters, that's all we need. Let's copy them first, then go back to connect endpoint. Here we can click on the Swagger interface, then click out, and then enter the specific parameters for Juniper. Here you can see. Alright, Juniper, execute for Juniper. This should be relatively faster. We can see the corresponding results and returns. Okay. Yes. In step 2, we have completed testing the device connection. We can use this endpoint to perform device status check, including connection verification. So we can know if the device is online and accessible via SSH. Now for step 3, we will demonstrate how to use the CMD endpoint to execute commands. When executing commands, we will first use curl to execute a show system info command. Let's execute manually to see the output. This execution on the PA. Good, that's the manual execution process. We get a system information, which includes details like the IP address, host name, and also its OC software version. The first number. We can also automate the process by calling NetDriver agent GMD endpoint. Next, we will use the built-in text SFM template in NetDriver agent to extract the host name and version number. First, let's use the curl command in bash for demonstration to copy the snippets. Start the call, let's exit first. Alright. We can see that the call was successful. Because we can open a endpoint and very fast we get the results immediately. Let's look at the parameters used. The calling parameters are mostly the same as before. The difference is in these parameters there is a continue on error parameter. It means that when we have multiple commands, command is an array and supports multiple devices in one call. So if the error occurs during execution, should we continue? or should be stopped and reported. If set to true, it will execute all commands without erroring out. If set to false, it will stop and report as an error as soon as one occurs. Now let's look at the return value. It's the piece of JSON code which might be a bit hard to read. We can use the formatted version right here. First, let's return the value code. For the code, awk means that the call was successful. If there's an error, we will have corresponding error code. Then message will contain specific error details if any exist. Time refers to in total execution time consumed, measured in seconds. Here it took 0.3 seconds. The result section is an array. Since we only executed one command, there will be only one result. The return code for this result is awk, indicating successful execution. The execution command was shown system info in return value, is in the output field. The purpose of output is to combine the return values from multiple commands, if there's more than one, for later reference, allowing us to record the entire execution process. We can simply copy the output result and paste it into our bash terminal. Then we can see this is formatted version, right? We can see this is exactly what executed in the shell earlier. This is all recorded in the way. So this way we have successfully obtained the device information via a single API call, executing the show system info command. However, these text outputs, while relatively easy for humans to read or even for AI to parse, are not ideal for programs. For a program to recognize what specific content is, we need to use template engines, the exact key fields. This allows our programs to perform corresponding functions based on the data. So the next demonstration, we will show how we can use TextVCM templates to extract fields from this command output. TextVCM is a template engine developed by Google. Its core uses regular expressions to match specific values. For example, here is a template sample. It defines a hostname and the version using patterns for non-empty characters. We can match hostname and software versions, extract these values and store them. Let's look. For this first software version, we need to extract software version. Let me find it. Yes, here. And also its hostname. We want to extract two values, of course. If we need more values, we can extract more. You can write corresponding template to achieve the extraction. So how do you specify this in the CMD call? We just need to change the command mode. Previously we saw our command was in raw mode. Raw mode means to execute the command without extraction, just returning a raw text output. If we need to use TextVCM, we simply specify the type as TextVCM. See, like here. Enable template. And an additional template parameter. Then we can obtain a result for this call. I will use Python to format the output, which will be clearer. Alright, after this call completes, the return value we get shows the difference from the previous one in the return section. Specifying the return value for each command. If we use TextVCM format, it returns the data extract after TextVCM parsing. Specify a hostname, a version and their values. The output field still contains the detailed execution log. There's a key difference though. Alright, we have now completed command execution. on the Palo Alto device and perform text execution using TextVCM. For this next demonstration, I will show how to perform some common changes on the Juniper device and how NetDriver agent automatically handles mode switching by specifying different modes. The process involves logging into the device, entering configuration mode, modifying its hostname, and then performing a save. Finally, we exit and run a show command for the hostname. We exit back to privileged mode and then run a show for the hostname again. That's the process. Let's perform manually first, of course. Clear. Let me clear the screen. Alright, let's first log into the enable mode. From here we can run show for specific values. For example, show configuration system hostname. Right. Currently its name is CRX6768. Now let's change the name. To do that, we need to enter configuration mode on the network device. For example, type configure. We are now in configuration mode. One in configuration mode, we use the command system hostname and change it to CRX. Alright. We then need to commit for the change to take effect. The commits might take a moment, or you can see the prompt change TRX. The host may visibly hide after the configuration has been committed. Now we can exit back to the previous mode, to the enable mode. In enable mode, let's run show command that we used earlier. We can see it has changed to CRX. That's a simple manual process. It requires typing many mode switching commands like configure or exit, and that's just for mode switching. If we use features like logical systems or VSES, because of those virtual routing functions, we will need to type even more commands and perform more mode switching. And because of that, we can utilize NetDriver agent, but by simply specifying the mode, it will automatically recognize the device's mode and perform the switch. Let's demonstrate this. But first let's exit. Let me clear the screen. Alright, let's copy this command. This is an API call. In this API call, we can see those connection parameters are the same. In difference in the commands, here are the formatted better. We have 3 commands. The first command is directly to configure by specifying configuration mode and set the host name to CRX6768. Then we commit in configuration mode. Then Then in enable mode we run the show command. It's the same process. Okay. Alright. This command call is taking a bit because of the lag. The call is okay, successful. We can see the author status is okay, meaning all succeeded. Each sub command was executed successfully, as you can see. Since it's in raw mode, each sub command has a log of its execution process. Even here. This complete log. Let's copy the entire log. And echo it to see it formatted out. We can see NetDriver prints some information to clearly display the execution process. The first command executed at specifying timestamp. First, since the current probe is in enable mode, and the command is specified to run in configure mode, we need to enter configure mode first. We use the configure private command to avoid conflicts with other users operating on the device simultaneously. Then, after entering the configuration mode indicated by the hash prompt, we can proceed with the hostname configuration. After the hostname is set, the command ends. Then we commit, which is also in configuration mode. Since we recognize we are in configuration mode, we directly use the commit. Finally, we need to run a show command in enable mode, recognizing we are in configuration mode, and automatically exits the enable mode and runs the show. Thus, the entire command is complete. Therefore, NetDriver agent is built-in automatic mode, and VSES switching capability greatly facilitates our development. Yep. Okay. To conclude today's demonstration, thank you for participating. To summarize, the demo mainly introduced just some features of NetDriver agent. We completed command execution, showcased the built-in text VCM templates in the automatic mode, and VSES switching capability. Going forward, you can follow our GitHub community and give us a star if you find the project useful. Also, check our other social media platforms and documentation for more details. In the future sessions, I will introduce you to a sub-project of NetDriver called Simunet, a very interesting project that allows us to simulate the CLA TTA of a network device. We also release some higher level courses to explain the NetDriver agent and architecture and advanced applications. Alright, thank you for making all the way to the end.